All right, let's talk about a question that sits at the very foundation of, well, pretty much everything. Is mathematics something we humans invented, or is it something we discovered?
I mean, just think about that for a second. What if the entire cosmos, from the way a galaxy spins to how a tiny particle vibrates, is all running on a kind of source code? And what if we, on this little rock in space, actually stumbled upon the language that reads it all? That's the huge, powerful idea we're diving into today.
But before we get to any cosmic blueprints, we have to start at the very beginning. Because, for most of human history, math wasn't about unlocking the secrets of the universe. It was about solving a much more immediate problem, like how many goats do I actually own?
Yeah, way before we had writing or big cities, our ancestors were using the simplest system you can possibly imagine. One scratch for one thing. These tally marks were basically the world's first spreadsheets, right? They were for counting food, keeping track of the seasons, managing livestock. It was a tool, pure and simple, born out of necessity.
Okay, so as society starts getting a little more complex, we need a better way to group all these tallies. And the solution, well, it was literally right in front of us. The huge majority of civilizations, all on their own, came up with a base 10 system. And the reason is so beautifully simple. We've got 10 fingers. It was just the most natural calculator we had.
But here's what's so revealing about that. It proves our whole system was a choice, not some universal law. Take the Yuki people of California, for example. They came up with a base 8 system. Why? Because they didn't count their fingers, they counted the spaces between their fingers. And it works perfectly fine. It just goes to show you that our entire way of counting is built on a very human, very biological convenience.
And that quote just nails how deep this invention really goes. I mean, think about it. If we had all used base 8, our idea of a decade wouldn't exist. Centuries would be different. Our whole sense of milestones and anniversaries would be off. Our superstitions, maybe that whole thing about the number 13, might not even be a thing. That one simple choice of how to count has quietly shaped our culture, our history, in ways we don't even see.
So, for thousands of years, math was clearly a human invention. It was a tool that we shaped and molded for our own needs. But then, a totally radical new idea started to take hold. What if some parts of math weren't invented at all? What if they were perfect, timeless truths just out there, waiting for us to find them? And this huge shift in thinking, it really comes to us from the ancient Greeks. People like Pythagoras and Euclid, they weren't just interested in counting stuff anymore. They looked at numbers and shapes and saw the keys to a perfect, unchanging reality that existed way beyond our messy physical world. For them, math was the language of the universe. To explore this hidden universe, they came up with an incredibly powerful tool, the axiomatic method. Now, the idea itself is actually pretty simple. You start with a few statements that are so obviously true you don't even need to prove them. We call these axioms. Like the shortest distance between 2 points is a straight line. Duh, right? And from just those few starting points, using nothing but pure logic, you can build or prove an entire universe of other truths. It was like a machine for discovering absolute certainty.
And for 2,000 years, this system, especially Euclid's geometry, was seen as the absolute pinnacle of human logic. A perfect, flawless structure of truth. But there was a tiny crack in the foundation. One little axiom that it didn't feel quite right.
It was Euclid's fifth axiom, the famous parallel postulate. It basically says, look, if you have a line and a point that's not on that line, you can only draw one single other line through that point that will never, ever cross the first one. Seems totally obvious, right? But here's the problem. Unlike all the other axioms, it wasn't really self-evident. It felt like something you should be able to prove. And so, the greatest minds in math for centuries tried to do just that.
And we're not talking about a quick project here. We're talking 2 millennia. From ancient Greece through the Roman Empire, the Renaissance, all the way to the Enlightenment, mathematicians were obsessed with this thing. They tried everything, every logical trick you can imagine, always thinking a proof was just around the corner. But every single attempt failed. It actually became known as the scandal of geometry.
And this quote, wow, it just captures the human toll of that obsession. Farkas Bolyai was a brilliant mathematician who basically broke his brain on this problem. He wrote this heartbreaking warning to his own son Janos, begging him not to fall into the same intellectual black hole. The hunt for this one little proof had literally become a source of despair.
But his son, Janos, along with a few other thinkers like Gauss and Lobachevsky, did something absolutely unthinkable. They just stopped trying to prove the axiom, and instead they asked a completely revolutionary question. What if it's not true? What happens if we just throw it out and replace it with something else?
And the answer just completely shattered the foundations of math. It turned out you could replace that axiom with its exact opposite, that through a single point you can draw lots of parallel lines, and you didn't get nonsense. You got a brand new, perfectly logical, and totally bizarre-looking geometry. This image here gives you a little peek into that strange new universe, a world we now call hyperbolic geometry.
So what does a world like this even look like? Well, some of the most basic rules we all learn in school get flipped on their head. In the world we know, Euclid's world, the three angles of a triangle always add up to exactly 180 degrees, no exceptions. But in this new hyperbolic world, they always add up to less than 180 degrees. It's a completely different reality, but it's just as logical as our own.
The legendary Carl Friedrich Gauss, who'd been secretly toying with these ideas himself, he just captured the shock of it all perfectly. This wasn't some mistake, it wasn't a paradox, it was a whole new world, a new geometry that followed its own perfect rules. That 2,000-year quest to prove that only one geometry was possible had ended by proving that at least two were.
So you can imagine, this discovery triggered a philosophical earthquake. If math wasn't this one single absolute truth that we were discovering, then what on earth was it? And this is really the key question, isn't it? If you can build totally different mathematical universes that all make perfect sense on their own, but they contradict each other, then which one is true? Which one actually describes our physical world? That certainty the Greeks were searching for just seemed to evaporate.
The mathematician Henri Poincaré offered a pretty radical answer. He basically said that asking which geometry is true is a meaningless question. It's like asking if the metric system is truer than the imperial system. They're just tools. We should use whichever one is most convenient for the job. And what's wild is that Einstein later proved that these weird, non-Euclidean geometries were the perfect tool for describing gravity and the fabric of space-time.
So this brings us right to the heart of the modern debate. You've got two main camps. On one side, you have the Platonists. They still believe that mathematical ideas are real, eternal things we discover, kind of like an astronomer discovering a new planet. And on the other side, you have the formalists. They argue math is just a really sophisticated game we invent. We make up the rules, the axioms, and then we just see where they take us. There's no external truth, just whether or not our game is consistent. Which brings us right back to where we started, but with a whole new layer of depth. Is math the actual inherent language of the universe, the code that existence itself is written in? Or is it just the most powerful language we've ever invented, a human tool so good that it lets us write the story of the universe ourselves? The answer, it seems, is still out there, waiting to be discovered. Or maybe, waiting to be invented.